Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, viewers, subscribers, and future engineers, students. This video is about work problems, and I hope that this will help you enhance your skills in mathematics needed in your engineering preparations. These types of problems really will help you improve and become better as long as you will master these types of problems. Very light problems, but in the future, you will use the knowledge and experience here in analyzing more difficult and challenging problems. Problem 21. The intake pipe to a reservoir is controlled by an automatic valve that closes when the reservoir is full and opens again when three-fourths of the water has been drained. The intake pipe can fill the reservoir in 6 hours and the outlet can drain it in 16 hours. If the outlet is open continuously, how much time elapses between two consecutive times when the reservoir is full? So take note of the situation, understand the situation. When the reservoir is full, this valve, the intake pipe will automatically closes, and since the outlet pipe is continuously open, it will drain the reservoir until such time that three-fourths of the water has been drained. And from there, automatically the intake pipe will be open again. And of course, the outlet pipe is always open. So there are two situations here. Let's consider first the starting point where the reservoir is full and the outlet pipe drains the reservoir. And we will call the time it will take the outlet pipe to drain three-fourths of the content of the reservoir as T sub 1. Then, when three-fourths of the content of the reservoir is drained, the intake pipe will automatically open and the two, one, the rate of the intake pipe is positive and the outlet pipe would be negative, and the time it will take for the reservoir to be full again is denoted by T sub 2. And take note that we equate both the fractional part of the work done to be three-fourths, not one, because the reservoir reservoir is not completely drained. So first, the rate of the outlet pipe is 1 over 16 times T sub 1 and equate it to three-fourths. So 1 over 16 times T sub 1 equals three-fourths. So meaning to say, when the reservoir is full and this drain pipe, outlet pipe drains the water until such time that three-fourths of the content of the reservoir is drained, then the time that elapses there is T sub 1. So T sub 1 is 16 times three-fourths and that is 12 hours. For the second situation, from reservoir with only one-fourth of its content remaining, so both the intake and outlet pipe are open, so work done by the intake pipe would be its rate, which is 1 over 6 times T2, then plus the rate of the outlet pipe, which is not contributing to the content but rather removing the content, so its rate is negative 1 over 16 times also T2 because both are open. Then only three-fourths should be added to the reservoir to make it full. So we equate it to three-fourths again. So 1 over 6 times T2 minus or plus negative 1 over 16 times T2 equals 3/4. In this case, the LCD is equal to 48. So 48 over 6 is 8. 8 T sub 2. Then minus 48 over 16 is 3. So negative 3 T sub 2 and 3/4 of 48 is 32. So 8 T sub 2 minus 3 T sub 2 equals 36 rather. 3/4 of 48 is 36. So T sub 2 is 36 over 5 and that is 7.2 hours. Therefore, that the time that elapses between two consecutive times when the reservoir is full is 12 plus 7.2 and that is 19.2 hours. So that's it for this problem 21. I hope that you understood the explanations and these equations here. Problem 22. One pipe can fill a swimming pool in 6 hours and another in 8 hours. If the first runs for 2 hours and then the second is opened, how long before the pool is full? By the way, if you want to anticipate the solution, you can always do so by pausing the video. Do not look at my solution here. Just compare answers afterwards because I think all or most of you, except for high school students, perhaps have already ideas on how to solve this. So one pipe can fill a swimming pool in 6 hours. The rate is 1 over 6 and that is positive. And another is 8 hours, that's also positive. If the first runs for 2 hours and then the second is opened, how long before the pool is full? We will call that time before the pool is full is as T. The total time where the first pipe is opened is 2 hours plus T, while the second pipe is only open for 3 hours. So 1 over 6 times quantity 2 plus T plus 1 over 8 times T is equal to 1 complete job. And that is the job is to fill the tank completely or to make it full. So 1 over 6 times quantity 2 plus T plus 1 over 8 times quantity T is equal to 1 complete job. The LCD is 24. So 24 over 6 is 4. 4 times quantity 2 plus T plus 3 times T equals 24. So this is 8. 4T plus 3T is 70. 8 plus 70 equals 24. 24 minus 8 is 16. Therefore, T is 16 over 7 hours. So that's the answer to that problem. Problem 23. A tank is filled with two pipes. The first pipe can fill the tank in 10 hours, but after it has been opened for 3 and 1/3 hours, the second pipe is opened and the tank is filled up in 4 more hours. How long would it take the second pipe alone to fill the tank? The two pipes have different diameters. So the rate of the first is 1 over 10 and the rate of the second is unknown. We will call it this 1 over T sub S, where T sub S is the time for the second pipe work open alone to fill the tank completely. Then the total time where the first pipe is opened is 3 and 1/3 plus 4, while the second pipe is only open for 4 hours. 3 and 1/3 is 10/3. So 1 over 10 times quantity 10/3 plus 4. That's the fractional part of the job by the first pipe. This is the portion of the pipe that is filled by the first pipe plus 1 over T sub S times 4 and it is equated to 1. So 4 over T sub S is 1 minus this value. This value is 12, 22 over 3, 22 over 30 is 11 over 15. So 4 over t sub s equals 1 minus 11 over 15. And 11 over 15 is 4 over 15. So 1 over t sub s times 4 equals 4 over 15. We can cancel 4, cross multiply, so t sub s is 15 hours. So that means the second pipe open alone can fill the tank in 15 hours. Then lastly, problem 24. A painting job can be done by 72 men in 100 days. So one complete job, one complete painting job requires 72 times 1,000 or 7,200 man days. There were 80 men at the start of the project, but after 40 days, 30 of them had to be transferred to another project. So meaning to say, these 80 men have worked 40 days initially. Then 30 of them have to be transferred to another project after 40 days. If the contract time is only 80 days, how many men should be hired 20 days after the 30 men had been transferred to complete the job on time? So meaning to say, after 20 days, when the 30 of them had to be transferred to another project, then we need to hire another number of men to complete the job. So 80 work for 40, 80 man, 80 times 40, then plus 80 minus 30. This 80 minus 30 over 50 men have work only for 20 days because uh, between 40 to another 20 days. Then since the contract time is 80 days, then there will be 20 days more where the hired X-men will also work together with the 80 minus 30 or 50 men. So we equate it to 72 times 100 man days. So this is the accumulated number of man days, 80 times 40. For the next situation, we have plus because 30 of them had to be transferred to another project. 80 minus 30 or 50 left working for 20 days. And after that, so this is the 60th day. After the 60th day, then there's a need to hire more men. So the current strength would be 80 minus 30 plus X, working for another 20 days to make it 40 plus 20 plus 20, 80 days. So 80 minus 30 plus X times 20 days equals one complete job, and one complete job is 72 times 100 man days. Simplifying, 3,200 plus 1,000 plus 1,000. So this is 1,000, 3,200. 50 times 20 is 1,000. Then we have 20 times X equals 7,200. So X is 7,200 minus 5,200. So 2,000. 2,000 divided by 20 is 100. So X is 100. So 100 men should be hired 20 days after the 30 men had been transferred to another project so that the job can be completed on time. So that's it for this video.